This conference will now be recorded.
So, good morning once again to one and all present here. So, today in the second session of our day 2, we have Dr. Anil Kumar Haritash with us. So, sir, on a very short request of our, has accepted the invitation. So, I would like to introduce Dr. Anil Haritash to all the audience. So presently, Dr. Haritash is working as Associate Professor in the Department of Environmental Engineering, Delhi Technological University. And he has more than 12 years of teaching experience and has around 17 years of research experience. Dr. Haritash's areas of interest is that environmental monitoring of polycyclic aromatic hydrocarbons, or shortly nicknamed as PAH, water quality assessment, wetland monitoring, advanced oxidation processes, and bioremediation. Sir has published around 65 publications in the form of research papers, conference abstracts, articles, and he has edited a book also. His research on biodegradation of polycyclic aromatic hydrocarbons has been conferred the status of fast-breaking research. I repeat that Dr. Haritash's research on bioremediation of PAHs has been conferred the status of fast-breaking research in environmental engineering by Thomson Reuters and Science Watch. Dr. Anil has been conferred state-level Outstanding Faculty Award for his contribution in academics and research. He is the recipient of Research Excellence Award of Delhi Technological University for the 3 continuous years, that is 2017, 18 and 19. He has been on the panel of subject experts in National Science Congress, Poland, Ministry of Drinking Water and Sanitation, Government of India, Shastri Indo-Canadian Institute, Terry School of Advanced Studies, etc. He is a member of editorial board of Indian Journal of Waste Management and Applied Chemical Engineering Journal. Dr. Haritash has participated in several national and international seminars, conferences, and workshops. So I am feeling highly privileged to have Dr. Haritash with us today. So now I invite Dr. Anil Kumar Haritash to please start his presentation. Thank you, sir. Please welcome.
Thank you, sir. Thanks for the kind words.
Thank you.
And if you allow, shall we start with the presentation?
Yes, sir. We shall start now.
I hope the screen is visible.
Yes, sir. Everything is fine. So you can switch on your camera if you want to.
Okay.
I think you have a pleasant personality and you must switch on it.
Wait a minute, sir. I am trying to adjust this bar so that we can change the slides easily, because it appears on the right hand side.
Okay.
Yes, I think it's fine.
Yes, sir. Yes, sir. It's good. Thank you, sir.
Okay. Thank you, Doctor. So today, this faculty development program on environmental geotechnology being organized by Shaheed Bhagat Singh State Technical Campus of Firozpur, Punjab. I shall be delivering a talk on solid waste management. And for the audiences, I work as a faculty in the Department of Environmental Engineering in Delhi Technological University. It was earlier the Delhi College of Engineering, and as per different ranking systems, the institute is considered as one among the best institutes in engineering. And we are fortunate that we got an opportunity here to work and to teach, to share our skills with the students. So, without much wait, we shall start. So, first of all, I would like to express my thanks to Dr. Bhagat from SBS STC for giving this opportunity, for inviting us for this faculty development program. And Today's lecture was scheduled to be delivered by Professor S.K. Singh. He is the head of department in DTU, our head of department. But he got some exigency in office and he messed up the responsibility to me. Hopefully, I'll be able to do justice what he expects and what audiences expect from this lecture on solid waste management. So thanks to both of them. Now we shall start with furthering the lecture. If we pay attention to the major environmental challenges that we are facing today, one of the most prominent environmental challenges is air pollution. And it is always said that air pollution is global in nature. It is not restricted to regional or national boundaries. Whatever has been produced in other corner of the world can get transported to our place, and whatever has been produced at our place may get transferred to the other corner of the world. And it disperses, it dilutes, it gets transported throughout the globe. So we call that it is global in nature, and therefore it is a shared responsibility of this problem. Air pollution, wherever it is occurring, it is because of the shared contribution of all the countries, and is a major challenge. And you must have read about in the news that almost all the major cities throughout the world are facing the problem of air pollution in one way or other. And there are number of interventions, number of policy measures that have been taken up to restrict air pollution, particularly in big cities. In India, we do have a problem, particularly during the winter season, wherein we face the episodic events of photochemical smoke formation. Of course, the northern part is well known about the problem of photochemical smoke, which is, as per some of the scientists, is because of the burning of agro residues in Punjab, Haryana, and Uttar Pradesh. But there are other sources also which are responsible for formation of photochemical smoke, and one of those are meteorological parameters. So it is, what I meant to say is air pollution is a big environmental challenge. And similar to air pollution, we have the problem of water pollution. Almost all the surface water bodies these days are polluted. We cannot expect any of the river that flows in its serene or natural state these days, the water quality being pure. All the streams, all the rivers, all the lakes, ponds, etc., have one or the other type of pollutant being discharged into it. And it would be hard to find surface water which is not polluted. Of course, in remote areas, there could be some locations, but at most of the places, it is being polluted. And it's not only the surface water which is getting polluted, the groundwater as well. There has been a rise in cases of or case studies related to groundwater pollution, particularly in, say, if we talk it in terms of the agricultural practices, then Punjab, of course, is facing a problem. Punjab as well as Haryana, Uttar Pradesh, the pollution due to pesticides. These pesticides have from the agricultural practices have from the fields have percolated down to groundwater and have caused contamination of groundwater also. It's not only the surface water which is being polluted. Of course, there are other sources, natural sources also, which cause groundwater contamination. And some of them are arsenic or lead or some fluoride. In some regions of Rajasthan, particularly, the problem of nitrate in groundwater is very pronounced. So this also, the water pollution also has got a major challenges that we are facing today. So these are two. And third is, of course, the solid waste. The solid waste management has become a challenge to almost all the places, all the cities, all the countries, all the regions. And with the increase in population, the quantity of waste being generated is also increased. At the same time, the complexity of waste has also increased. Earlier, the solid waste would have been the simple food waste, which was easily biodegradable. But with the advent of technology, new materials are being synthesized, chemically synthesized, and one of such materials is the plastic. And after one time or two time or multiple uses, the plastic is ultimately going to find its way in the environment. And since many of the people, particularly in developing countries, are not very aware about what could be the harmful effects of this plastic if disposed of as such in environment if it litters around. So this has become a major problem, the solid waste management, almost all everywhere around the globe. We are not specifically dealing with the data, but it is a major problem for everyone these days. And as the population is going to increase, as the pace of development is going to accelerate, production as well as problem of solid waste is going to accelerate. Now, the problem of solid waste is not only about its management. Solid waste is also causing other problems which are related to it. And what could the other problems be? The solid waste associated land degradation. Wherever the solid waste is, be it biodegradable in nature, be it non-biodegradable in nature, be it toxic or non-toxic, wherever it is being disposed of, it is first of all leading to land degradation. Whatever waste is disposed of at some place, it is going to degrade physically, chemically, or biologically. It is going to disintegrate. And the disintegrated portions may be hazardous, may be non-hazardous. Those which are hazardous and toxic in nature are ultimately going to leach down into the land, into the ground, into the soil. And these would ultimately cause environmental toxicity, ecotoxicity, and would be causing in different forms of harmful effects, directly or indirectly, on short-term basis or long-term basis. Many times we observe the effects immediately, but at times we do not get the effects immediately. Rather, these effects are witnessed after say 10 years, 15 years, or more number of years. So, solid waste is not a problem in isolation. It is also a problem which is resulting in acceleration of other problems that we are facing today. Land degradation is one of the major problems we are facing today. Leave the case of solid waste aside. Even then, land degradation is a major problem. And added to it, if solid waste is being disposed of, is being littered out, then it is accelerating the rate of land degradation. So it's not only solid waste, it's also the other problems which are getting accelerated because of this solid waste. And it's not only land degradation, it's also water pollution. You may witness number of sites which appear to be highly polluted, which appear highly unaesthetic, which appear highly harmful. And one of the reasons for these problems related to water or water pollution is solid waste. Whatever has been disposed of in water, which remains in dissolved form, may not be visible to us. But what this picture shows is clearly visible. And it's not something which has got dissolved because of some natural reason. It is the human activities which have resulted. It is the ill management of solid waste which has resulted in water pollution also. And such features, such obstruction, physical obstruction in different processes may also delay the natural reclamation rate of the water bodies. So solid waste, we said, it accelerates the land degradation. It also accelerates the rate of water pollution. Again, this is not confined to land and water only. Solid waste is also resulting in air pollution. This is one of the very common sites that you can encounter outside the cities or even within the cities. This is a big amount of big heap of garbage or the waste which is being disposed of in landfills. And since anaerobic disintegration, decomposition of waste takes place and methane is produced, there are fair chances that these landfills catch fire easily. And once the landfills catch fire, the waste keeps smoldering for a long period of time, and the smoldering results in the emission of lot of gaseous pollutants, lot of particulate, lot of obnoxious pollutants, and lot of toxic gases into the environment. So it's not only associated to that, and this picture may seem to be smaller or local in scale with respect to its effects. But the similar smoldering, similar burning of landfills can even be visible even through the satellite pictures. This is one of the landfill in Mumbai, which accidentally caught fire and it kept on smoldering for weeks. And this could be recorded even through a satellite image also. And you can easily see the smoke which is getting traveled to other places. And fortunately, the wind is carrying it towards the sea. The wind direction could get reversed also, and these pollutants, these impurities, these gases, the smoke, etc., would be carried along the land also. And you know about the population density in Mumbai or some other city. So it's not only the problem of ill management of solid waste is not only causing land degradation or water pollution, it's also responsible for air pollution. And when it comes to the landfills are a good source for the emission of methane, which is a greenhouse gas. And therefore, landfills or common dumping grounds are also considered as sources of greenhouse gas emission into the environment. So what I wanted to convey with these few slides is that solid waste is not a problem in isolation in environment. It's a problem which is accelerating the other environmental challenges, other environmental problems also, and which are broadly classified as water, land degradation, or air pollution. So how can these problems, these challenges be attended to, be restricted? For this, if the solid waste is managed properly, we have a few advantages of this management, effective management of solid waste. And this would be firstly reduction in air pollution if the waste management is done effectively. Second, it can reduce the land degradation or soil contamination or soil degradation. It can also reduce water pollution. The three are very, very much visible in broader terms. And these could be encountered even by a layman in environment, anybody can witness these things. But the last 4 points are also very, very important, which are not witnessed by a layman. Of course, as engineers or as scientists or as academicians, you do have an idea about these things and you have read about, you understand about it, but the layman can know that if solid waste management is being done properly, it can reduce the waste associated toxicity in different environmental components. For a common man, for a layman who is not known about the toxic effects of plastic in environment, say the microplastics, etc., for them, disposing of or throwing out the polythene or plastic in open doesn't cause any harm. But of course it does. The scientists, the engineers, the other persons who are known about the harmful effects, they know that proper management of this plastic can significantly bring down the toxicity, which otherwise would be imparted to different compartments of environment. And these different compartments are water, land, or air. The management of solid waste can also help extract useful components from it. For an example, paper, once newspaper is read, it becomes waste. Anything which is of no further use is classified as waste. But the same newspaper, if it is being sold to a scrap dealer, you will be having some money in return. At the same time, this waste goes for recycling, and this newspaper may be recycled again and again. And that way, a useful resource, useful component from the waste can be extracted. Suppose, there are other examples also. We commonly use these days. Whenever we travel, we use water bottles, the plastic bottles. Once the water is drunk, and even if some water is left out, the general tendency is to crush the bottle and throw it out. But the same water bottle can be reused. Of course, there are studies, there are issues which state that these plastic bottles may have micropollutants, microplastics present in it if these are used again and again. But the good quality plastic, the virgin plastic, particularly the PET plastic, polyethylene, terephthalate, etc., which are not where addition of some other bisphenol A, BPA, etc., has not been done, those can be reused. And what we are doing otherwise also at home, we buy some fancy looking bottles, plastic bottles, and we keep using them. So of course, for us, this plastic bottle once used can be a waste, but for others, even for us also, this could be resource also. We can reuse it. There would be reduced burden over the natural resources also, as we quoted the example of recycling of newspaper. So otherwise, if the recycling of newspaper is not being done, the paper for this making of paper, the other trees, forests, etc., would be cut, and there would be extra burden on the natural resources. And this is a simple example of paper. There are other components, other products which are made up of different natural, which are taken up, or which are made up of the material which is extracted from different natural resources. Of course, if we are reusing, recycling, and recovering, in that case, the burden over the natural resources is removed. and we help maintain a better environment. And that everybody must have witnessed it during the COVID scenario, that our dependability on different products which we buy from market, from outside, has decreased. People have restricted to homes and haven't gone out, and the use of different resources, different products in environment in the market has also reduced, and that has resulted in better environments these days. So that reduction in burden over the natural resources, of course, giving you back a good environmental quality, which will be of benefit to the population, whichever is exposed to not simply human beings but other organisms as well. It also minimizes the harmful effects and maximizing the economic benefits. As we said, simple case of recycling. So the recycling can simply lead to economic benefits also. There are number of recyclers, number of scrap dealers who are making good business, who are making good economic profits, simply being in the business of recycling. For someone who doesn't have much idea about economic aspects of recycling, this could be appearing as a job of a scrap dealer, a job of a rag picker, but for them it is a profitable business, of course. So this solid waste management is also one of the way of maximizing economic benefits. Otherwise, we shall be more dependent over the other sources, other environmental sources. So these are the benefits. Now, how do we define solid waste? Any material which is of no further use to us may be defined as solid waste. Any material which is of no further use may be defined as solid waste. The refused material which cannot be reused again is defined as the solid waste. So as I said earlier, a person who has used a water bottle of drinking water for someone very specifically, for that individual, if he refuses to use that bottle again, that becomes a waste. But if the same person is using that bottle again and again for say 10 number of cycles, until unless it is refused for further use, it doesn't become a waste. So it is the refused material which has no further use. The term further is very, very important here. As long as it has some use, it cannot be classified as waste. But as it gets refused for any further use, it becomes a waste. And for this solid waste, the waste should be a solid state. But there is an exception. The gaseous or liquid waste can also be treated as solid waste if it is stored or if it is contained in a container. Container could be plastic, could be metal, could be glass, anything else. So even the liquids or gases can also be classified as solid waste if these are stored in a container. Broadly, the solid waste, if we know about the technicalities, the basics of solid waste, the management is quite easy. It's very, very easy. So the waste can be characterized on the basis of type of waste, what sort of waste it is. Type of waste here refers to if the waste is biodegradable or is non-biodegradable. If the waste is recyclable or non-recyclable. Most of the food waste is decomposable, it is biodegradable. And it is classified as one of the important category of decomposable waste. Whereas the other type, the paper, plastic, glass, metal, etc., these are classified as recyclable materials. And in waste, these are classified as recyclable. So broadly, type of waste here refers to the two different types. These two different types are decomposable waste and recyclable waste. Within decomposable or recyclable waste, there could be different items present. For example, for the recyclables, we said the items could be paper, plastic, glass, metal, leather, fabric, etc., etc. Secondly, the waste can also be characterized based on the source. Now, based on the source, the properties of waste would vary. Suppose the source is agricultural. All the waste which is coming from agricultural activity would be biodegradable in nature, would be decomposable in nature. But if the source is institutional, it would be recyclable as well as decomposable if it is institutional. The food waste would be making the fraction of decomposable, whereas all the paper, plastic, packaging, etc., would be constituting the recycling material. So with respect to source also, the waste is classified, and based on the source, we can determine what characteristics that particular waste is carrying. It's agricultural, it is decomposable. If it is institutional, most of it is recyclable. If it is domestic, most of it is again decomposable, because from the households normally, the food waste is the primary waste produced. Apart from it, the dust, ash, silica, etc. is also produced. Based on the quantity or size of the waste also, we can classify the waste. Based on the quantity or size, it can be classified as the fine waste or the bulky waste. Normally, the construction and demolition waste is classified as the bulky waste, since it is more dense, it is larger in size, and mostly if it comes to household waste, it is fine sized waste. And the waste can also be characterized based on composition and toxicity. The toxicity here refers to if it is toxic to environment or if it is non-toxic. The normal domestic waste or the food waste is non-toxic in nature, but the industrial waste could be toxic in nature. So that way also classification of waste can be done. Next is based on the type of waste as we were discussing. First type is discard. Now these terms have specific technical meanings. Discard is the waste which can be used after treatment. Suppose a glass bottle contains milk in it. The milk is used and the glass bottle is discarded. But this glass bottle will not be considered as waste. It would be considered as a discard, since it can be reused after treatment. And the treatment here in this case could be washing the bottles, sterilizing the bottle. So anything which can be treated and which can be reused becomes discard. So glass bottles, newspaper can easily be recycled, and therefore it would be considered as a discard, not a waste. Metals normally can be recycled. Recycling is a type of treatment that we are providing. So discard is that fraction of waste which can be reused, which can be recycled. So this term is very important. Discard is not waste. It is one of the component of waste which is useful to us. Second is garbage. And garbage is generally the decomposable fraction or the biodegradable fraction. It is the food waste. Food waste, mainly the kitchen waste that is produced, the peelings of fruits and vegetables, and the leftover food also is a part of garbage. The garbage is also produced from household activities, from the lawns, etc. The grass clippings, leaves, twigs, etc. Those also are a part of biodegradable fraction. And the rubbish is the waste excluding garbage. Excluding garbage, whatever remains as a waste is called the rubbish. Normally the plastic, paper, glass, leather, etc. is part of rubbish. Trash is the inert fraction now. Out of the rubbish, trash is the inner fraction which contains glass and metal. It is generally the non-reactive fraction which remains as such for a long period of time. There is another fraction which is combustible. Rubbish has two parts, two different components, trash and combustible. Combustible is the one which burns easily, which has good combustion properties, which can be burned and energy can be recovered from such waste. So based on the type, the waste can be classified as discard, garbage, rubbish, trash, and combustible. Now, based on the source, as we said, domestic waste, commercial, agricultural, industrial, construction and demolition, and automobile waste. Automobile waste is also bulky waste, and it is mostly metal and plastic in nature. So, based on the source, it can also be classified, and the properties of waste produced from a definite source would vary. The waste management has a certain scheme for its treatment. The first and foremost is estimation of waste generation. Whatever you are going to manage or treat, the scope, the scale, the quantity of that waste is to be known. If you do not know how much is the quantity, how much is the scope, how much is the volume being produced, your arrangements may be deficient in nature. These may not be sufficient to tackle the waste, or otherwise can also happen. You may gather lot of resources, but the waste generation would be less. In that case, it would be wastage of resources, wastage of money and time. So therefore, it is very, very important to first of all estimate the waste generation, and waste generation in terms of quantity is being done. Secondly, when the estimation of waste is being done, we'll have to collect the waste, because the waste is not produced at a central place, it is not delivered at a central place on its own. It is being produced individually in different houses, in different activities, in different sectors. So the collection of that waste is an important part of waste management. And third is segregation of waste. Sometimes the waste, depending upon its properties, may be mixed in form. Suppose decomposable waste is mixed with recyclable waste. So the recyclable waste in this case, in mixed form, cannot go to recycling, and the decomposable waste cannot go for further treatments in form of composting, etc. So initially, separation of these recyclables and decomposables is to be done. And once segregation is done, management gets very, very easy. Third is transfer and transport. Now these second and third steps, segregation of waste, transfer and transport, these are interchangeable. Sometimes the segregation of waste is done at source, sometimes it is done at the treatment facility. In Indian conditions, mostly the waste remains mixed in form. Transfer and transport is done, and then the waste is segregated at the treatment facility. But in the regions, in the countries where waste management is very effective, in that case, in those cases, the segregation of waste is done at source. And once segregation is done, things get very, very easy. Both is recovery and recycling. Whatever discard is present in the waste. Now the term is very important, discard. Whatever discard is present in the waste, that can be recovered and recycled. Discard is that waste which can be reused, which can be recycled. So recovery and recycling is very, very important process. Intermediate processing sometimes of the waste is also required, where burning, stabilization, etc., is required before finally disposing the waste into a landfill. And this is once the waste is treated, once it is managed, some fraction remains which cannot be treated, which cannot be managed. In that case, that part of the waste goes to landfill, and it's not dumping. The dumping has different meaning, and landfilling has different. Dumping means throwing the waste out in open, without following any scientific principles, without following scientific ways of for disposal. Where landfilling is based on the scientific principles. So dumping is similar to littering around. If the waste is tied in a polythene bag and is thrown out in open in an empty space, this would be treated as dumping. So many times people say that the waste is dumped in landfills. So dumping has different meaning and landfill has different. Dumping is throwing out in open and not dealing with the waste in scientific way. Now the first important step is estimation of waste generation. The waste quantity of waste is expressed in kilogram per capita per day, and it's abbreviated as KGPCD. And this may also be expressed in tons per day, particularly for the cities. And this can also be expressed in tons per day, tons per annum, in terms of annual generation of waste per country. So most of the times it is expressed in kilogram per capita per day. For the state or for the country, it is expressed in tons per day or tons per year. And the waste generation is regulated by certain factors. This is very important to understand what are those factors which regulate waste generation. Once the cause is understood, once the diagnosis of a problem is done, it becomes very easy to treat the disease, treat the problem. So first and foremost factor which governs waste generation is standard of living. Higher the standard of living, more is waste generation. Because with high standard of living, we have better capacity to pay for the products. Where income is high, generally standard of living is high in high income group, and they have enough money to pay for different products. Suppose it's a layman in a village, the person would be using a simple soap for washing the clothes. But when it comes to cities and when it comes to elite communities, they could be having different types of detergents. Some particular type of detergent, say Rin or Tide for the washing machine, for washing the woolen clothes, they would be having some other soap in the form of the Easy or some other product. For washing some other type of product, they could be relying on some other other type of soap. Similar to the person who is in a village would be having a simple toilet soap for bathing, also for washing the hands also. But those who are residing in cities, they would be having number of different products. For hand wash would be different, the toilet soap would be different, and face wash would be different, shampoo would be different, conditioner would also be different, and different cosmetic products would also be used. So based on the standard of living, we get more access to different products, and more the use of different products, more is the waste generation. So standard of living significantly affects waste generation. Higher the standard, more is the generation of waste. It's also depend. The second factor is availability of resources. Higher the availability of resources, more is the waste generation. Suppose at some particular place, some particular resource is not available. Say forests are very limited, paper is very limited. In that case, people would be using the paper very wisely. They would be recycling it, using it to the minimum extent possible. But at the other place where paper is abundantly available, people would be using it, people would be wasting it in abundance. So availability of resource significantly governs. India is an agriculture dominated country, and we have enough abundant grain production in India, and therefore we afford to spoil the grain, particularly during the monsoon. You must have heard over the news, you must have seen it, that during monsoons particularly, the grain markets fail to manage the grains properly, and a big quantity, big chunk of the grains is spoiled during monsoons because these are available. Had this not been the case, if the availability of those grains would have been limited in India, this is for sure that that grain would not have gone wasted, be it any kind of weather. So availability of resources significantly governs. If we know that we have good availability of plastic bottles everywhere around the cities, so we have general tendency to use it and throw it out. But if we know that we will not be getting a plastic bottle for refilling the drinking water at some particular place, there is a perfect possibility that the person will not be throwing that water bottle out, and whenever he finds a source, would be refilling it and would be reusing. So availability of resources significantly governs the waste generation. Though it appears to be simple, but it can make a huge difference when it comes to reduction in waste generation. Thirdly, geographical location, climate, seasons, etc. also govern. Say particularly in colder regions or polar regions, people use minimum resources and generate minimum wastes. Whereas the population which is around the equator has more access to different products, they are using more of the products, they need to use more products, and therefore the waste generation from these equatorial regions based on the climate is also more. In the winters, the use of different materials, different products is relatively limited, whereas in summer it goes up. A simple example is the use of tissue paper or the cloth, the tissue which we are using for wiping the sweat, perspiration, etc. is very common during the summers, but winters we generally don't use such products quite often. The next is education, awareness, and sensitivity. These are three important factors. Most of the people, we may say that India, most of the population is educated, but the population should also be aware about the harmful effects of different wastes on environment. Although the population is educated, but many of them are not aware about the harmful effects of plastic on environment. They are not known about the micropollutants which are present in environment. They are not aware about the different gaseous pollutants which are present in atmosphere. And even if some population is aware about these harmful effects, they are not sensitive. People need to be sensitive at the same time. There would be number of audiences, number of participants within this meeting who know about the harmful effects of plastic, but they do have a tendency to throw out the plastic bottle because they are not sensitive to environment. So level of education, level of awareness, and level of sensitivity is very, very important in regulating the waste generation. Legislation and enforcement is again very, very important. I have heard it from a number of people that when you visit some foreign country, people are very afraid of spitting out in open or throwing the waste in open because they will be fined immediately at the same place. So legislation, if it is as stringent in India, of course there would be, the waste will not be littered around, and it will not be, uh, it would be easy to manage the waste. Lifestyle again governs it. People in villages generally have the such lifestyle of reusing and recycling the materials, whereas in cities where availability of resources is abundant, the lifestyle is such that reusing and recycling is generally not preferred. Sometimes religious beliefs, customs, traditions, etc. also govern waste generation, though to smaller levels. Say customs and traditions or fairs and festival when it comes, generally during the month of or during the week we celebrate Diwali, a lot of waste is being generated from house. Whatever remains in the houses as waste, unused, discarded material is generally thrown out. So particularly during this festival season, lot of the load over the landfills or load over the waste management machinery increases. So sometimes in other countries, this generally happens during the Christmas. Most of the waste would be generated during the, because people buy gifts, those are packed, and the packaging material is a waste. So particularly during that season, the waste generation is related. Now, the quantification of waste is generally done, as we said, in per capita per day, and the waste generated in a year, it is divided by the population and the number of days in a year, that is 365, and that way we arrive at the waste generation. In India, we have an average waste generation of 0.5 kilogram per capita per day, and the figures may be different for the present day conditions. This could be around 0.6 kilogram per capita per day. But these figures are being given by Central Pollution Control Board based on the data that they get from different cities, different states for waste generation. And this waste is also measured, generally the waste generated in a year. This figure is arrived at by getting the mass of the waste. Generally, the mass can be obtained by multiplying the volume by density. Volume of the truck which is delivering the waste to a landfill facility is known, and if it is multiplied by the density, it gives us the mass. But in Indian conditions, under Indian conditions, the waste which is arriving at a landfill, the density is not constant. It varies from load to load, from the truck to truck. And therefore, this first formula of determining the mass or the weight of the waste which arrives at a landfill or generated in a year doesn't fit under Indian conditions. Rather, in this case, all the trucks which are arriving at the landfill facility are weighed. The weight of those trucks is known, and this is generally done at each hour. A representative number of trucks, suppose within an hour, 15 trucks are arriving. So 2 trucks would be weighed per hour, and based on the average, the total number of trucks that are arriving, the total weight of the waste is calculated. This is a simple arrangement that is generally followed for determining the quantity of waste being generated in a year. Now, characterization of waste, this is very, very important. Once characterization of waste is understood, the logic associated with waste management is also understood. If we get to understand the properties of waste, we can easily determine what sort of treatment, what sort of management is to be given to that type of waste. And this characterization of waste with respect to the volume can be done based on material flow methodology. The first approach of material flow methodology, it can easily be followed in developing countries. What happens is the data related to different products which are sold in the market is maintained accurately. If the data related to n number of products is known, we also know what quantity of waste would be produced by an individual type of product. Suppose if it is a toilet soap, the toilet soap has packaging material as waste in it. Suppose a 100-gram bar of toilet soap produces 5 gram of packaging waste. And if we know that n number of this product, this n units of this product have been sold in the market in a year, n multiplied by 5 will give you the amount of waste produced by this one particular product. Now, if the similar data for n number of products is known to us, it's very easy to calculate the total waste generated by n number of products in a year in a particular region. But here, under Indian conditions, the data related to different products is not properly maintained. At the same time, there are number of products, particularly with respect to food material, where the waste generation or data or quantity is not maintained and it remains locally left. Suppose someone is producing a particular type of food crop in a field, the data related to this field crop will not reach to the market. And in that case, the waste generation for that particular type will not be there. Rather, we depend upon the second approach of direct field study. In case of direct field study, we collect sample from the source or collect sample at the treatment facility. The general tendency is to collect the samples from treatment facility. Whatever waste is reaching to the treatment facility, representative samples of that waste are collected. Now, the sample should be representative. This should not be biased. Suppose a truck arrives with the waste filled in it, and the waste is obnoxious, it is smelling very bad, and the person who is given the responsibility of collecting the waste is biased and doesn't want to enter into that obnoxious environment, says, okay, you go and dump this waste, I'll not be collecting a sample from this one. This smells really bad. In that case, the sample may not be called representative. So the samples should be representative. These should represent the composition, the characteristics of the waste as a whole. And this should be sufficient in number and these should be precise. So there is a specific code for characterization of waste. This code is ASTM D5231 and it defines the protocol for sample collection and its characterization. So sample collection, the collection of sample or the sampling is done by 4 different ways. First type is composite sampling. In case of composite sampling, the waste is collected as a bulk waste in composite. And in case of coning and quartering, the waste is collected, a cone of that waste is made, and it is quartered. It is divided into 4 parts, and 1 part is taken as a representative sample. Column sampling, we generally cut a column out of the waste, and these are few different techniques. Here in this first case, this is called a composite sampling. In case of composite sampling, from over the landfill, we collect a different number of samples, and these samples are mixed together, and this mixed sample would act as a composite sample. This type of approach is called the composite sampling. The second approach is coning and quartering, where a sufficient amount of the waste is collected and it is laid in the form of a cone, a heap. The top of the cone is pressed. Once pressed, this is divided into 4 parts, and 1/4 part, 1/4 of this cone would serve as a sample. This should be representative again. So coning and quartering is similar to composite sampling, but different only in the case that we take 1/4 sample out of the composite sample in case of coning and quartering. But this third type is bulk sampling. In this case, we collect a bulk sample and it is generally collected using a front end loader. A front end loader is generally a crane with a front end which is used for a hopper which is used for loading the waste. But in this case, in case of bulk sampling, when this loader collects the waste, it has a tendency to push the bulky waste away. And the heavy, smaller waste would easily be collected. The bulky, light waste would be collected, would not be collected, would be pushed away. So this bulk sampling is generally not preferred until unless we are very sure that the waste is represented. Sometimes from within the waste, we cut the cores, we cut the columns, and these columns are used for representative sampling, representative characterization of the waste. Now the segregation of the waste is done, and as per the rules, the place where segregation is to be done, that yard should have at least 1,000 square feet of area, and the different components which are present in the sampled waste. Now, whatever waste has been sampled, the different components of that waste are to be separated: paper, plastic, glass, metal, etc. These are sorted, and these are put into designated containers. Now, once the weight of the sampled waste. Suppose initially we collected 100 kilograms of waste. Out of this 100 kilograms, if paper, plastic, glass, metal, etc. are sorted, put into different containers and are weighed finally. Finally, हम उनका weight ले लेते हैं. उसके बाद we can know what percentage of these different items is present in the waste. That way it is being done. And the segregation of the waste is done manually. So individually, these components are segregated, and these components, these individual components, once these are weighed, these are powdered, these are ground, these are shredded. Now, whatever can easily be shredded, whatever can easily be segregated, is collected as that particular item, either paper or plastic or metal or glass. But out of the sample which has been collected, some of the waste is difficult to be segregated. Some of the waste cannot be segregated. It becomes really difficult if it is decomposable food waste or paper in it. So that part, the waste which cannot be segregated, is reported as ash present in the waste. So that way, segregation and characterization with respect to different components is being done. Now, based on the sampling, based on the segregation, based on the characterization, particularly for Indian waste, this is the fraction. For nearly 42% of Indian solid waste is decomposable waste, is the food waste. Almost 40% is the ash. Now recall the point that we just discussed. Anything which cannot be segregated, anything which cannot be separated easily is classified as ash. So Indian waste, because it is mixed in nature, lot of the discard which can be reused and recycled go as ash in mixed form. Paper is around 6%, textile 3.5%, leather is around 1%, plastic is around 4%, metal and glass is respectively 2 and 2%. And this is based on the data published by Central Pollution Control Board in the year 1999. The composition may vary slightly for the year 2020, but more or less, these would be the fractions that we generally obtain. So the characteristics of Indian waste here is, most of it is biodegradable in nature. Suppose this easily segregable, easily separated waste, biodegradable waste, is taken out and sent for composting, right away, we are putting 42% load out over the landfill. Whatever was reaching to the landfill in mixed form, if biodegradable waste is taken out and is sent for composting, almost 42% load over the landfill is removed immediately. And if we address paper, plastic, metal, glass also, those which are given in green color, the paper, plastic, metal and glass, these can easily be recycled. And the recyclable fraction goes to the recycling vendors. Generally, the newspaper once read at home is not thrown out, because newspaper has got a scrap value. We sell it to the scrap dealer. Similarly, plastic, metal and glass is also sold. But the low density plastic, particularly LDP, low density polyethylene, it is not being sold because the weight is very less and the volume occupied by such waste is more. It is generally not sold and is thrown out. But the rag pickers in solid waste management hierarchy are an important segregators who take out the plastic from here and sell it to the recycling. But there are issues related to recycling that we should be addressing very soon. Now, once the individual components, paper, plastic, etc., are understood, we go for the analysis of waste. And for the analysis, there are two different approaches: proximate analysis and ultimate analysis. In case of proximate analysis, the moisture content, volatile organic content, ash content, and fixed carbon content are determined. And these four parameters, more or less, determine the properties if the waste can be burnt or not. Higher the moisture content associated with the waste, the burning properties would be poor. Higher the volatile organic carbon and fixed carbon content, the calorific value of that waste would be high. And higher the ash content, it is not preferred to burn that waste. Generally, burning results in almost 80 to 90% reduction in volume and mass. If the ash content associated with a particular waste is high, we generally don't burn such waste because even otherwise it's not resulting in much reduction in volume or mass. So it's not advisable to burn such waste. So proximate analysis is generally done to determine the combustion related, heat related properties of waste. It is an approximation of different characteristics possessed by waste. And the other, these are few of the values of proximate analysis. And based on these values, when you find out that calorific value of say paper is quite high, that of newspaper is also high, whereas in other case the green logs of wood, generally wood is used as a fuel, but the green logs since have more moisture content would be having low calorific value. On the other hand, the rubber, plastic, PVC, etc. would be having very high calorific value, but these are not advisable to burn plastic, etc. because they in turn causes air pollution. But if this particular aspect is overcome, in that case, these can be burned, these can be converted to pellets, which can be burned in different industrial operations. So the other type is analysis. The other approach is ultimate analysis. And in case of ultimate analysis, apart from the normal properties of moisture, ash, etc., we also determine the elemental composition of carbon, hydrogen, nitrogen, sulfur, oxygen, chlorine, phosphorus, etc. And it is also referred to as elemental analysis. Ultimate analysis is also referred to as elemental analysis. Once the percentage fraction of these elements in the waste is known, it becomes very easy to calculate the heat associated with the waste. The calorific value of the waste can be determined easily if the elemental composition of these elements is known, of the waste is known. And in case of ultimate analysis, generally carbon has maximum content, followed by oxygen, then hydrogen, nitrogen and sulfur, phosphorus, etc. are relatively less. And this is a simple characterization of ultimate analysis of different components present in waste. The third is determining the heat value. The heat value can be determined even for the raw waste without the elemental analysis. And this is the equation given by Abu Karara and Khan. The two authors have given this equation, and this equation can be used to determine the high heat value associated with the waste. High heat value is the total heat released by the waste. And this also contains the heat which is required to remove the moisture from the waste. Whereas once the moisture is removed, whatever heat is produced by the burning of the waste is referred to as low heat value. And lesser the difference between high heat value and lower heat value means lesser is the moisture content associated with the waste. And therefore, more would be the heat associated with such waste. If that waste can easily be burned. And this heat value or the combustion properties of waste are very important when we devise a strategy for the management or treatment of waste by burning it. And burning the waste as such, suppose in Indian conditions, the waste reaches to the landfill as mixed waste. If the mixed waste as such, without segregation, is being burned, in that case, the facility is known as mass burn facility, where the waste is burned as such in mass, in bulk. But if the waste is segregated and the components of waste which have lower calorific value associated, particularly food waste, etc., which have high moisture content, if it is removed and the other paper, plastic, etc., if these are segregated and then burned, in that case, it is called as refuse derived fuel, RDF. So the facility where it is being burned is classified as MBF, mass burn facility, or RDF, refuse derived fuel facility, based on if we are carrying out the segregation of the easily combustible waste or not. But in order to classify them as easily combustible or not easily combustible, high calorific value or lower calorific value, we need to carry out the heat analysis, the calorific value analysis of the waste. So once these properties are understood, then it becomes very, very easy to manage the waste. There are different equations which can be used for calculating the heat value associated with the waste. Generally, Boy's equations, Chang's equation, and Dulong equation, these three are very popular. But among the three, Dulong equation is the most preferred model. Most of the researchers do study the Dulong's equation. They use this Dulong's model to determine the heat associated. Of course, apart from these three, there are a number of other models which can be used for calculating the heat associated with a particular waste. Now, once the characterization of waste is done, once the properties are understood, then starts how to deal with the waste, how to collect, transport, and manage it. So MSW collection, the municipal solid waste collection, is very, very important part. It is very important with respect to maintaining a public health, because the waste, if it keeps littering around, it also causes public health hazard. It also causes a possibility of spread of some disease, and therefore this collection is very, very important. In India, the collection of the waste is of the order of around 70%. 30% of the waste is probably not collected. And this figure is an official figure, 70% in India. But unofficially, it could be less or it could be slightly higher also. So that depends upon the conditions, depend upon the system working at a particular place. So in Indian conditions, we have approximately 70% collection of the waste. But in higher income countries, in developed countries, it's almost 100%, is of the order of 98%. But in poor countries, in developing countries, this could be as low as 40%. So if you can imagine the situation when only 40% of the waste is collected and is delivered to the treatment facility, rest 60%, a major part of the waste is causing different environmental problems. So collection is very, very important, and improving the collection efficiency should be targeted as for effective management of solid waste. So waste collection, it's from the point of production to the point of treatment. Whatever waste is produced, that should be collected and is to be delivered to the treatment facility. And it is generally the responsibility of municipal authorities to collect the waste, to transport it, and to deliver it to the treatment facility. Now, there are different methods for the collection of waste. Although collection of waste appears to be very simple approach and doesn't involve any scientific principles in it, but as far as waste management is concerned, collection of waste is very, very important step. If the waste is not collected, it is going to produce different environmental effects. But once it is produced and is managed effectively, those environmental effects would be restricted. So waste collection, this should be paid a proper attention to. There are two different methods for waste collection. First is community bin collection. In this case, in case of community bin collection, normally a community bin is placed at one particular location. These bins are placed generally at the corners of a street so that people living in a particular community deliver this waste to that facility, drop it to the community bin. And these are generally placed along the corners. Community bins are also placed at places where movement of a vehicle through the streets is difficult. The vehicle which is used for collection of waste. If the streets are narrow, the vehicle will not be easily able to maneuver through those streets, and in that case, this would be difficult to collect the waste. So what they do is they put a community bin at one of the corner. All the residents of that particular community will deliver their waste to the community bin, and that would be collected from the community bin by the municipal authorities. So community bin collection system appears to be somewhat like this. They place two bins for decomposables and recyclables at one of the corner. So whoever is residing in that particular community, locality, will be delivering their decomposable waste into the green bin and the recyclable waste into the blue bin. And that way a municipal van would arrive at this place, would empty the containers, and this collected waste then would be delivered to the treatment facility. So this is how the community bins are generally placed. Now, wait a minute, excuse me. The community bins sometimes are also placed along the roads. When the volume of the bins is slightly more, in those cases, these bins are placed on the road instead on the streets. But there is a problem when such bins are placed over the roads. Normally, the stray animals, dogs, pigs, cows, etc., those stray cattle, etc., generally they try to find some easily eatable waste in the bin, and they generally have a tendency to litter the waste around. Also, if this emptying, if this waste is not collected from here by the municipal authorities on regular intervals effectively, in that case, littering would be observed. And this waste keeps on collecting. Once it is littered around, once it is stored here for a day or two, it starts smelling really obnoxious, really very bad. And in that case, whoever comes from a residential locality to deliver the waste at this place will not be reaching next to this bin, rather would generally have a tendency to throw it out from some distance. They will throw the waste near to the bin from some distance, and that way the waste keeps piling. And with the movement of these vehicles along, some of the lightweight waste easily gets scattered with the action of. So that way, this collection systems, they have certain limitations, they have certain drawbacks as well. Now the other type is house-to-house collection. This is also referred to as door-to-door collection. In case of door-to-door collection system, someone who has been assigned the responsibility visits every house, rings the bell, and collects the bills. And many of us would have encountered this house-to-house collection system also. In this case, say particularly for a high-rise building where apartments are made, someone who is designated for collecting the waste blows a whistle, and listening to that whistle, people from individual houses would deliver the waste to this cart, and she will be delivering the waste to a designated place from where the municipal van, municipal truck would deliver it to the treatment facility. So as long as this waste collection system, house-to-house collection system or community bin collection system is quite efficient, quite effective, the waste management is also quite effective. Sometimes what happens is people in particular localities are educated, are aware, and are sensitive. What they do is they collect the waste produced in an individual household separately as decomposable and recyclable. But when it is delivered to the person who collects the waste, the person is not that educated or trained. And what he or she does is mix both types of waste. So whatever was segregated at the source has been mixed during collection. So collection has this process, this step should also ensure that the waste does not mix, the segregated waste does not mix if it is segregated at source. So this is quite important. And what at some particular places it is being done is there are different vans which arrive at for the collection of waste. This is, don't go after the spelling, this is for the garbage collection, and garbage is the decomposable fraction. So one particular van comes on daily basis, and the decomposable waste is delivered to this van. Only the decomposable waste. This waste directly goes to the composting plant. And once a week or twice a week, a blue colored van arrives for the collection of recyclable waste. And that would collect the recyclable waste, will deliver it to the recyclable vendor. That way, the load over the landfill is significantly removed, and whatever was present as a resource in the form of waste is recovered. So that is the beauty of segregation at the source. In developed countries, what is being done is, this is called curbside pickup. Curbside pickup is also known as door-to-door collection. In this case, the dustbins are placed outside the houses. A truck or the van arrives and they collect the waste. They empty the waste into the container and take it out. In those countries, it is almost an automatic system. The problem of stray animals, stray cattle is generally not encountered, but similar system cannot be adapted in India because the dogs, cattle, etc. would be littering, taking out all the waste out of this dustbin, and this would be littering around the roads. So that's the difference between collection system between a developing country and a developed country. Generally from institutional areas in India also curbside pickup is being done, but it is restricted to institutional or industrial areas and to certain cities only. It's not observed on a national level in all the cities. Now, some of the waste which is hazardous in nature, or the biomedical or industrial waste, it is self-delivered or contracted. This is not collected by the municipal authorities. Such waste, biomedical waste or industrial waste, is delivered to the waste treatment facility through the contractors. So there are a number of different contractors, or these are self-delivered. The industry itself has the responsibility to deliver this waste to hazardous waste treatment facility. Generally, you might have observed similar sort of vans which deliver the biomedical waste to the treatment facility. Now, transportation of the waste is also important. Once it is collected, it is to be transported to the treatment facility. And this is an old system which was being used, not particularly in India, but in developing countries. Two different containers or open carts were pulled by a tractor. And one of the cart is for recyclable, the other cart would be for decomposables. And the recyclable and decomposable waste are put in different containers. These are not mixed during transportation. In India these days, we have moved to crane trucks containers, where the containers which are placed at a community location, these are picked up over the gate, an empty container is placed here, the filled up is taken in and is delivered to the treatment facility. There are other methods also. Normally in some of the countries, we still do have the rear loaded trucks. The normal trucks are used for the collection and transportation of the waste, and the loading is also done, the loading too is done manually. This is the case in some of the cities, still being done in some of the cities. But in some of the cities, it has become almost automatic, or we may say it has become semi-automatic, and you will be able to differentiate between the sanitation status between these two places. It is relatively better. The exposure to the personnel involved in collection and transportation of the waste is relatively less. Here in this case, it is more. Now, there is other limitations also. Even if it is done using a crane, sometimes the waste is such. You can see the fibers, the threads are running along. Even the front end loader fails to load the waste into it. So in that case, manual labor is required to help load the waste and transport it. And sometimes the waste which is being delivered, transported to the treatment facility, remains open in this truck. Hauler remains open. And in this case, when the truck is moving, the lightweight polythene, plastic, etc., keeps littering around. So this sort of collection is not very effective, is not very efficient, and it rather exposes the population to harmful effects, to the smell, etc. Now, there are certain points which need to be remembered during waste collection and transportation. The first is the time required for waste collection. Sometimes the time required for waste collection is less than the time which is required for waste transportation. So time required for collection should be maximized. Time required for transportation should be minimized. Because once the time required for waste collection is maximized, the number of households served would be more. So more number of households served means better collection efficiency. And the volume of vehicle, etc., is to be determined. Optimization of route is also to be done, and that involves certain mathematical expressions which are used generally to calculate it. This is how the time required for waste collection is calculated. Time required for waste collection can be represented by capital T, and it is the time that a truck requires to reach from the parking facility to the site of collection. T2 is the time required from collection location to the facility where the waste is dumped or treated, and how many rounds does the truck make or N by 1. And finally, the truck reaching from the disposal facility to the parking facility is the time T3. That way, these expressions are used. These are given in hour, and capital T, the time required is the total time. This is 8 hours under Indian conditions, 8 hour shift. And that way we can calculate TC, the time required for the collection of waste. Higher the time required for collection of waste, better is the collection efficiency at a particular place. And this is how we can determine the number of spots, number of stops the truck makes, number of households that the truck serves. Although this is a picture of a book, but this is an expression generally used for determining the number of stops. And this expression is used to determine the volume of the truck, and this depends upon the volume of collection vehicle. It depends upon the average volume of the refuse, individual stops, and the compaction ratio if the weight is compacted. These days we are generally shifting to open trucks to the compactors. If the waste is compacted, the compaction ratio is considered, and N is the number of stops that the truck makes per. Then comes economics of waste collection, and for this economics of waste collection, we will have to determine the annualized cost of vehicle and infrastructure, which can be determined by the simple expression. Those who study the engineering economics must be known about this formula. The annualized cost of truck as well as the infrastructure required for waste collection and management can be calculated, and the annual cost for the labor can also be determined. Both can be added, and once added, the total cost on annual basis required for handling waste is known, divided the total weight of the waste divided by the annual cost will give you the cost required for handling per ton of the waste. And that way we will have to make different permutation and combination, different volumes of the vehicles, and we'll have to finally make a decision which particular volume, which particular route will be optimized for the waste collection. Now, once the waste is collected and delivered to the treatment facility, then since we said in the Indian waste is rich in decomposable fraction, almost 42% is decomposable, and decomposable waste can easily be treated by composting. And composting is done with the help of microorganisms. In case of composting, the waste is delivered for pulverization. Pulverization is simply breaking it down into smaller pieces, and then it is moistened. The pulverized waste, moisture is added to it, and it is laid in the form of long-running heaps, and these heaps are known as windrows, and microorganisms would be acting upon this waste to turn it into simple compost. The compost can then be stabilized and can be reused. Whatever does not remain, whatever does not go for composting or which is inert in nature, go out as reject. And the final compost can be reused in the fields finally. Immediately before this lecture, Kumar was presenting, was saying about circular economy. This is an example of circular economy, where the waste, which is biodegradable in nature, is composted, and the compost is prepared. This compost finally goes to the fields, and from the fields, the agricultural products, etc., are there, which is finally producing the waste. In that way, the decomposable waste enters into a circular economy, the eco-sanitation facility. So composting is one such treatment method for the biodegradable waste. We won't go into the details, but it is simply by microorganisms, is easy to operate, and it can reduce almost 42% load over the landfills in Indian conditions. The second method for decomposable waste is vermicomposting. Here, the difference between composting and vermicomposting is that in case of vermicomposting, we are using earthworms also. Certain microbes are also involved here, but earthworms carry out the major task, and whatever biodegradable waste is there is mixed with the earthworms. Earthworms are gregarious feeder. They feed a lot over the biodegradable matter, and the secretion, the cast which are given out are called vermicasts, and these vermicasts are sort of compost, and this compost can easily be applied to the fields, etc. And these days, even the government is proposing for composting or vermicomposting of kitchen waste, even at domestic level. This can easily be done. The agricultural waste can be mixed with some already prepared compost and earthworms, and these earthworms keep feeding over the kitchen waste, and they gradually turn it into the rich compost, which can be used in horticulture, gardening, etc., etc. The third type is biogas generation, where the biodegradable waste is sent to a biogas, and This produces methane. The methane can be used as a fuel. These days, these biogas plants are operated at a larger scale. Even the sewage sludge is used and methane is produced. And this methane runs gas engines or gas turbines or generators and is helped to produce electricity. And this electricity is directly fed to the grid. This way, whatever this facility is, be it industry, be it a domestic plant, be it some other agency, whatever units of electricity are produced by this unit, by this biogas plant, fed to the grid would be subtracted from its energy load. So that way, the government is also promoting waste to energy conversion. Here, the waste is converted to another form of energy, which is methane in this case, and methane is finally converted to electricity. So such type of systems where waste to energy systems are also preferred these days. One of the example is mass burn facility and refuse derived facility also, where the waste is burnt as such to attain heat, to get heat from burning of the waste. Liquefaction is mixture of oils, where the waste is generally converted into mixture of oils. And gasification is mixture of gases. Biogas generation is another type of is an example of gasification. Sometimes thermal conversion is also done, particularly for the agricultural waste. So these are the different strategies. The first three are more popular, which can be adopted for decomposable waste, and these are easily practiced. Not much technical know-how is required in this. The next comes recycling of plastic. It is very, very simple. Whatever plastic is present in the market today, almost 15 to 20% is thermosetting, which can be recycled again and again. And these plastics, broadly, the recyclable plastics, are classified into 7 different categories. There are specific symbols. Many of you might be knowing about, some of you may not be. These symbols, the 3 chasing arrows in a triangular, running in a triangular fashion, are a symbol for recycling. And the name given here is the type of resin required, the resin out of which this plastic is made. So symbol 1 is for PET. PET is polyethylene terephthalate. We generally use PET bottles and PET containers. This is for in the kitchen. HDP is high density polyethylene. Third is PVC. PVC is polyvinyl chloride, and it is not that much recyclable. The recyclability of PVC is relatively less. LDP is polyethylene, low density polyethylene. PP is polypropylene. Polypropylene is also used for making food grade containers, the bottles and other containers. And PS is polystyrene. Now, if classification of these plastics, if segregation of these plastics is done effectively, these can be recycled n number of times. But if the segregation is not proper, and even a ton of PET, when it is recycled, and even 10 kilogram or 15 kilogram of HDPE goes into PET, the whole lot would be contaminated. In that case, this moves to the category 7, where it is mixed plastic. So as long as it is virgin plastic, it is one resin, it can be recycled a number of times. So recyclability is very, very easy. But unfortunately, those who are involved in waste management, the rag pickers, scrap dealers, recycling vendors must be knowing about it, but scrap dealers, rag pickers, they do not know what type of plastic resin it is, if it is HDPE or PET or PVC. The plastic bottle that we are using, if you look at its bottom, there would be a sign there, and within the sign, this recyclable sign, there would be a number written. This number signifies what type of plastic it is. So recycling of plastic, it is very, very easy, but one should take care of what sort of resin it is. If the resin is easily segregated, recycling is very, very easy. And recycling is also based on the color of plastic. If transparent plastic is to be recycled, all the lot of PET should be transparent. If you add one green colored bottle of PET to it, that lot gets contaminated. When it comes to, Recycling of paper. I said paper recycling is very, very easy. Newspaper, it is after collection, it is de-inked. De-inking is done with the help of certain enzymes. It is also done mechanically using some physical and chemical processes. Also, the ink is removed. Once the ink is removed, uh, final cleaning is done, and then it is mechanically a pulp is prepared. That pulp is finally fed to the paper making machine, and the paper is made. The paper again goes back to recycling. That way, recycling of paper can easily be done, and it is being done at many of the places because we do not have that much rich forest resource with us that we get enough number of paper for fresh paper making all the time. So this is broadly the municipal solid waste management scheme, where the role of the rag pickers, the scrap dealers, etc., is very, very important. These are the different sources from the waste is generated. So through the rag pickers, reaches to scrap dealers, to scrap wholesalers, recyclers, and it goes to recycling. So that way, municipal solid waste management scheme works. We had a discussion about the landfills also, and these landfills can be classified as type 1 The landfill has different components, and these components, the one of the most important component, whatever waste cannot be treated goes to landfill, is the liner provided at the bottom. The liner must be impervious. It is generally the recompacted clay. The clay is generally impervious, and along with the clay, geotextile membrane is also used. Normally, a HDP layer is used, high density polyethylene is laid at the bottom, which makes it impervious, and the waste is filled here. And this waste, whatever waste is filled here, is regularly monitored, regularly covered, and finally sealed over with the top cover of the landfill. We won't go with the details of landfill, but the landfills can broadly be classified into three types: type 1, 2, and 3. Type 1 is for municipal solid waste. These are referred to as sanitary landfill. Type 2 is for particularly for fly ash and is referred to as designated landfill. And type 3 landfills are for hazardous waste, are known as secure landfills. There is particular siting criteria for the landfills. Whatever place we site for landfilling, that should be able to serve for the next 10 years, at least next 10 years. There should be sufficient land available around that place for the receiving area, leachate treatment, evaporation ponds, etc., etc. And there should also be some space to generate a buffer around the landfill. It should ideally be a natural depression, a barren or infertile land, and the underlying stratum or the bottom layer should be impervious ideally. There should be sufficient availability of soil and clay to cover the waste at regular intervals, and the landfill should not be placed on a seismic zone or fault, because in some of the cases it may get punctured and the waste may leach down, may contaminate the soil or the groundwater. It should not lie on the route to natural drainage, otherwise the water would be entering into it and it would be carrying the waste along. And it should easily be accessible within 30 minutes of travel time, because lesser the travel time, more would be the collection time, more would be the number of households served here. And it should be preferably an existing network of road or railways, and groundwater table should be at least 1.5 meters below the base of landfill. And this difference of 1.5 meters is to be maintained during monsoons. Because summers, this would be more, but during monsoons, it should be at least 1.5 meters below the base of landfill. This should be sited at least 3 kilometers away from the turbojet airports, and should be away from the floodplains. This should also be away from sensitive zones, uh, like hospitals, religious places, etc. Wherever a landfill is placed, there should be sufficient arrangement for monitoring wells, where the groundwater quality is monitored upstream as well as downstream of the landfill, so that the leaching or the leaking of landfill can be monitored. There should be sufficient arrangements for collection and flaring of gases, treatment of leachate. Fencing should be provided, and entry of stray dogs, cattle, animal, etc. is to be avoided. Unauthorized entry should also be avoided, and the top cover, which seals the landfill, should regularly be monitored, should regularly be checked for leakage, etc.
So this is how a sanitary landfill, the liner is laid. Initially the clay is laid and the clay is compacted, over which a layer of HDP, impervious geomembrane is laid, and then we start filling up. These are the specifications of the liner which is laid. It is generally 24 inches of compacted clay over which a geomembrane is laid. Then we lay this leachate collection system. The structural fill is required, which allows easy percolation of the leachate through this structural fill. And the geomembrane sometimes is also, secondary geomembrane is also provided. This is particularly in case of hazardous waste landfilling. And then the waste is refilled in such places. Whatever waste is placed on daily basis is called a layer, and this layer should be covered with soil on daily basis. So what generally is observed is the waste is taken to the landfill site and it is dumped as such. It is being landfilled, but on daily basis the waste should be covered using at least 6-inch thick layer of soil, so that the vectors, disease-causing organisms, birds, scavengers, etc., have a restricted interface with the waste. An intermediate layer is also to be laid. Once the landfill is filled to half of its volume, this should be covered with a layer of 12 inches thickness of compacted soil or clay. And the landfill finally, once it is over, it is to be covered. And the landfill, this should not reach to a level more than 3 meters above the ground level. But what happens in cities normally, the landfill sometimes reach to say 10, 15 or even 20, 30 meters over the groundwater, ground surface. And the cover is to be placed here. The top cover of the landfill is topsoil is laid, the solid waste is present there. The gas, there should be sufficient arrangement for gas venting, and the gas should be collected and should be flared, treated and flared. And the barrier should be such that it does not allow the gases or to escape and the precipitation, the water, etc., the runoff, etc., to enter into the landfill. So finally, the landfill, whatever waste is placed there, should be sealed, and this sealed landfill should be maintained, should be monitored regularly for a long period of time. They should not be used for making residential complexes or residential buildings. It should be used, ideally should be used as a park or recreational sport or an energy park. And these days, what people are doing is, whatever landfill, once it is sealed, they are laying solar cells over this landfill, so that the solar energy which comes over the landfill is harvested and it can be fed to the grid. So it is used as an energy park these days, and access to other people's is also avoided. That way aesthetics is also maintained, and even the top cover, the seal of the landfill is also maintained. So that's how we do it. The general tendency to manage the waste effectively is reduce, reuse, and recycle. And these are general practices that can be followed in waste management, even at individual level or domestic level. And this is the hierarchy. We will have to first try to reduce the generation of waste, and whatever waste has been generated should be reused. Whatever cannot be reused should be recycled. And recycling, even if recycling cannot be done, the waste can be used for energy recovery. It can be burned and energy can be recovered. It can either be transformed to some other forms in biogas, etc., and energy can be recovered. Whatever cannot be treated remains finally for disposal, and this goes to the landfill. So disposal is the least favored option, whereas reduction, reuse are the most favored options. And there are different factors where technical know-how, on-site services related to waste management, the recovery, the recycling, the legal compliances, the rules, regulations, etc., which are there, and the education level, awareness level, etc. Finally, all these will have to come together for an integrated waste management. With this all, we conclude today's lecture on solid waste management. Thank you. It's over from my side. Singh ji.
Thank you, sir. Thanks a
If
lot.
we have any questions or queries, we can.
Audience, if anyone wants to ask any question to sir, please unmute your mic.
Do you hear me?
Yes, Mitan Das ji. You can
Yeah,
proceed.
yeah. Good afternoon, sir. I'm Itandas. I am from West Bengal. My question is, sir, I did not understand about the pulverization process and stabilization of solid waste.
Okay. Pulverization is generally done to increase the treatment efficiency. Suppose if it is decomposable waste, it is biodegradable waste. If it is present in larger pieces, the surface area of that waste would relatively be less for the microorganisms to act upon. If it is pulverized, it is shredded into smaller parts, it becomes easy to treat, easy to handle. So microorganisms would be having more surface area to act upon it, and the rate of biodegradation in case of composting would relatively be more. Similarly, if it is vermicomposting, there would be smaller pieces of these food particles available for the worms, and the rate of degradation, rate of feeding of these worms over the waste would be more. So pulverization is normally done to increase, to expedite the rate of treatment, rate of degradation. And in case of stabilization, stabilization is generally done for the toxic or hazardous waste, because toxic or hazardous waste can leach to groundwater, leach to other components of environment. If some toxic waste is left as such over the soil, these toxic impurities during precipitation, during rainfall, etc., may leach into the soil and may ultimately reach to the groundwater. But once the mobility of these toxic impurities is arrested by some ways, one of the example is making fly ash bricks, as Jeet Kumar Gupta ji was discussing in the earlier lecture. Fly ash has certain inorganic components, particularly heavy metals present. If it is left as such, during precipitation, those heavy metals can leach down and leach to soil or leach to groundwater and may contaminate it. But once it is mixed with the cement, these heavy metals become stable, become immobile within the fly ash bricks. So that is referred to as stabilization of waste. So fly ash in that case was a waste, and the stabilization using cement to make it into a brick has led to stabilization of heavy metals or the inorganic impurities which are normally toxic in nature. So normally stabilization or solidification is done for toxic impurities.
So,
Is
any
it
other
okay?
participant? Sir, someone is asking the average lifespan of landfills.
That depends upon the area of landfill.
Okay. Thank you.
Because if the area is larger, you plan it in a way that it can accommodate the waste generated for next 20 years, the lifespan would be more. And once it is closed, the stabilization would take long time. It generally will take around 20 to 30 years for stabilization once it is sealed. But if a landfill is smaller in size, which is maintained for the next 5 years only, the waste present in it would relatively be less, and this would stabilize in relatively smaller period of time, maybe in next 10 years. So that depends upon the size of the landfill.
Anyone else? Participant?
Hello.
Hello, sir. Hello, sir.
Yes.
Hello.
Yes, yes, sir. My another question is, sir, in case of landfill, in the slide I have seen that there is a topic that repairing about scavengers. Sir, what is the meaning of that term?
Scavengers. Okay. Say if the waste is left in the landfill as such, so certain rodents, rats, mice, etc., would be attracted to that waste. And putrefaction, decomposition of this waste in the landfill would be resulting in breeding of disease-causing microorganisms also. These disease-causing microorganisms through these rats or the birds or the flies, mosquitoes, etc., would be reaching to us and may cause some disease. So rats, flies, the rodents, birds, etc., may be classified as scavengers in this case, which can bring the pathogens from the landfill to us. They would be called scavengers.
Thank you, sir. Anyone else?
Hello, sir. Good morning, sir.
Good morning.
Hello.
Yes, yes.
Sir, I am Trishulpani from Hyderabad, sir.
Okay, please say.
Sir, is there any particular machinery to convert that chicken waste every Sunday we are seeing chicken waste, non-veg waste or fish market waste to convert into compost?
This can be amended with the compost, with the food waste, the other food waste, the vegetable waste generally, the kitchen waste. But if the quantity of this fish waste or chicken waste is more and that of the vegetable waste is less, in that case there could be problems. This needs to be mixed with more of quantity of the vegetable waste and that can be sent for composting. But this cannot be sent for vermicomposting, I think, because the smell of fish or the meat chicken waste would repel the worms. It pushes them away. That smell is that obnoxious smell. So better it can be sent for some other treatment. And generally, the tissue waste, the chicken waste or fish waste, this should ideally be treated in a separate facility because this has the tissue, the flesh, the meat inside it, and certain fraction of blood also. So that becomes a good breeding ground for the organisms, even disease-causing organisms. So preferably this should be treated separately. The eggshell can be mixed with general composting material.
Thank you, sir.
Any machinery, sir, to convert them into manure?
So,
Thank you, sir.
Okay, Bhagat, thank you very much. Someone
you,
asked
sir.
about the e-waste management, but e-waste management is different. There are certain organized sectors, organized industries which deal with the e-waste. And what they do is they take out the useful material from the e-waste, it is generally recovery, and that goes for recycling. So the organized sector is working in e-waste management, and at some places the unorganized sector, the illegal sector is also playing a role. They keep on segregating that waste, e-waste. So that becomes a different part, e-waste management.
thank you, sir. So,
Okay, thank you,
I
Singh.
I think, thank you, sir. So we must conclude here. So sir has given us a wonderful knowledge about the various environmental issues which are prevailing today in our society, like water pollution, air pollution, and then their remedial measures from solid waste management. Then there are other waste associated land degradation as well as waste associated water pollution methods. And sir has also discussed the importance of this waste management very beautifully. So I hope we must implement at least one line in our daily life, that is 3 R's. That is to reduce, reuse, and recycle. So I think this is the mantra of this lecture or this solid waste management. So thank you, sir, for such a nice and wonderful session, and hope to see you tomorrow morning again with the another topic, that is soil remediation. So thank you, sir, once again. On behalf of our organizers, I thank you once again. Thank you, sir.
Thank you, Doctor. Thank you. Have a good day.
Thank you, sir. Thank you. Thank you. So participants, we will again assemble at 2:30 p.m. So till then, have a good day. Thank you.